Here at CSU East Bay in the Science Error Defense Division, we are training students to minimize error. Beginning students learn precision moves with meter sticks. Advanced students combat error with laser accuracy. But the best defense against error is a trained mind. Here, a student is asked to measure the thickness of a single piece of paper using only a ruler. He can't because the piece of paper is smaller than the 1 millimeter divisions of the ruler. Instead, he realizes that if he takes a stack of 50 pieces of paper, he can measure it with the ruler. Suppose we wanted to measure the thickness of 1 nickel. Using a ruler, we measure it to be just about 2 millimeters. But of course, there is an uncertainty of at least 0.5 millimeters. That's a fractional uncertainty of 0.25 or 25%. So the thickness of the coin has only been measured to an accuracy of 25%, 2 millimeters plus or minus 25%. That's terrible. A better technique would be to measure the thickness of 10 coins together. That comes out to be about 19 millimeters. The uncertainty is still the same, 0.5 millimeters, but that means that the fractional uncertainty is nearly 10 times smaller, 0.026 or 2.6%. So the thickness of 1 coin we get by dividing by 10, which also decreases the absolute uncertainty by a factor of 10 to 0.05 millimeters. But the fractional uncertainty in our result is still 2.6%. So the thickness of the coin is 1.9 millimeters plus or minus 2.6%. We have increased our precision a factor of 10 by using 10 coins instead of 1.
Random error will propagate throughout calculations everywhere.
Suppose you're calculating the area of a rectangle. It looks like the uncertainty in x is a little bit bigger than the uncertainty in y. What's the uncertainty in the area when we take the product? It's not all that clear. Instead, we express the uncertainties in terms of percentages. Now we see that the uncertainty in y is much bigger than the uncertainty in x. By the weakest link rule, the uncertainty in the product will be the percentage uncertainty of the larger of the two percentages, so 10%.
With random error, we shall destroy the accuracy of student experiments everywhere.